I see this immediate, thank you.
Yeah, she's leaving you after this anyway, babe.
Yeah.
She's going so long. So guys, we're going to spend 10 or 15 minutes together going through one question. I've just developed this document just a little bit earlier because what's been happening is, like, if you've had a look at the practice test, you know what kind of questions are going to pop up, okay? So you know there's going to be a question on it, finding the equation of a tangent and normal, all right? So it's like, make sure you can do that. You know there's going to be a question on the properties of a function using calculus techniques. Differentiate it, draw a sine diagram, use your calculator. Okay? There's going to be easy marks. They're sort of the easy marks, right? You have to get them. And then there's more complex questions, isn't there? There's going to be one about graphing relationships. Okay? Here's a function. Now draw its derivative, draw its second derivative. There's going to be a conjecture problem. All right? There's going to be an optimization problem. Kinematics and a rate of change. We can anticipate, we've got good inductive evidence to suppose, based on the previous test, this is the kind of things that are going to be asked. So and these, like, most of them start easy, but they do ask harder parts as it goes on. Like, for instance, the conjecture, that's this sort of ominous looming dark cloud. We know there's going to be one in there, and we know it's going to be hard, but let's break it down. Okay, so that's what I've got up here is some strategies for us to apply when we're doing a conjecture problem. So they range from between sort of 6 to 12 marks all up, or maybe a little bit more. And early marks in a conjecture question, they'll start easy and they'll just be like, find the derivative, show that it's this, and so forth. You have to get them, and all you have to do is just whatever it tells you and use your calculator. So I'm going to go through this one whilst referring to the conjecture strategies, because I want to point out where we should be earning marks, where we shouldn't stress, and what we should do even if we don't know what to do. I'm going to give you something that you can do to get some marks. Okay, because remember, our goal is just get as many marks as you can. Let's go through, we're going to go through 14. Now, I've indicated to some of you to have a crack at 14, and 14 I want to go through in particular because there's a strategy here that I want to highlight as we're going through it. So, question 14 from the conjecture booklet. You're very welcome to just watch, you're welcome to write. We'll go through it together and use our calculators and so forth. So, consider the function f of x is 2 on top of x take 1 plus 2x. A graph is shown below with two stationary points at A and B. Alright, so there we go. And we read this carefully. It's talking about stationary points. Okay, so already we should hold that in our mind. Now, part 1. Show that f dash of x is this. Okay, so given the function, which is 2 on top of x take 1 squared plus 2x, show that f dash of x is this equation here. So, we have to get those marks. They're easy marks to get. All you're doing is differentiating this and showing that it's the same as what they want you to have there. So if I'm going to differentiate this, first I need to move that to the top. You can do the product rule, although it's not a very efficient way of doing it. You can do the quotient rule, although it's not a very efficient way of doing it. We move it to the top, and now we can just leave the 2 there and do the chain rule on this component. So we'll do the chain rule. Make sure I put the question out properly. I've got, it's not squared, it's just on top of x take 1, isn't it? 2 on top of x take 1 plus 2x. Good, okay, so let's differentiate it now. So here's the function, now we're moving to the derivative. So the 2 is going to hang out, minus 2, x take 1 to the power of minus 2, multiplied by the derivative of that part will be 1. And then we have derivative of 2x is just 2. Okay, so we get 1 mark for differentiating it, and we're going to get the second mark for manipulating this such that it equals that. We need to show that it's the same as that. So what do we have then? We've got minus 2 on top of x take 1 squared plus 2. So if I'm going to bring those together, I need them to have the same denominator. At the moment, this doesn't have a denominator, so we're going to give it one by multiplying it by this denominator. So then what we've got they're the same denominator, so we can bring them together over the top of x take 1 squared. All right, we can add them together. We have minus 2 plus 2 lots of x take 1 squared. And now it's just going to be a matter of expanding that and collecting like terms. Now, any time the question says show that, you absolutely must show everything. Do not skip any steps. Don't assume that the marker knows what you're doing. Exhibit it very clearly. So, I'm going to leave the 2 out and perform the perfect square expansion there first. All on top of x take 1 squared. And then I'm going to distribute the 2. And then I'm going to collect the 2's there. 2x squared take 4x on top of x take 1 squared. QED. Okay, so we have to get those marked. Part 2. Hence, using an algebraic approach, show that f of x has 2 stationary points at 0 and 2. Okay, we have to use algebra to show that this original function has 2 stationary points. Okay, stationary points, what does that mean? Slope is horizontal, it's not increasing, it's not decreasing, so that means the first derivative equals 0. So we go stationary points when f dash of x is 0, so that means 2x squared, take 4x, on top of x take 1 squared, equals 0. Alright, that's the first part, that's what we're trying to solve. Now, because it's a rational function, equal to 0, we're only considering the numerator. We completely disregard the denominator. Alright, we're trying to solve this algebraically. I'm going, what's common to both sides? 2x. If I expand this, this is what I get, and then null factor law. Okay, so we've shown it's stationary, the slope is 0, at x is 0 and x is 2. Okay, so a further 2 marks there. Alright, now consider the function g of x equals 2 on top of x take m plus 2x. Okay, so here they're introducing you to the general function. Our general function, it won't always be g of x for general, but it's our general function because it doesn't have a number here. This is what they're changing, all right? They've introduced you to it. Consider this family of functions. And then there's this plus 2x, where m is a constant and x and m are not equal. And then look at the table that we're presented with. Okay, so we're still in the early stages of marks. All right, look at that table there. We can see this is the number that's changing. M is changing. And so all we're asked to do is find what's the x coordinate of the 2 stationary points of the function. So here, you absolutely must use your calculator. Do not try to do all that manually. This will say 1 mark here. 1 mark, possibly 2. 1 mark. All right, so what we'll do, we'll go to our calculators, we'll pull out, we're going to go into the graph mode. We're already given the first one, so we're going to go straight to the second case. 2 on top of x take 2 plus 2x. Now we're not interested in the derivative function. We're not told a v window, so we just keep it as standard. All right, I'll just set mine as standard so we've got the same one. Okay, that's what it looks like. And we can see 2 stationary points, okay? One where my mouse is now, and the other one down here. And so we need to g-solve those. We've got a local max there, x is 1. So to fill in the table, maybe I'll type it in rather than all right, and you guys go through and get the others. So we have 2 on top of x take 1 plus 2x. 2 on top of x take 2 plus 2x, 2 on top of x take 3 plus 2x, 2 on top of x take 4, 2 on top of x take 1. Alright, so we've got 0 and 2, we've got 1 and then we'll G solve them in. 1 and 3. I know what they're going to be, but I'll just coach you through how we get these values. We exit out. Okay, we change that number at the bottom. Now we want 2 on top of x take 3. And we repeat the process. Okay, you can only just see the function there. We know there has to be another stationary point, so adjust accordingly. G solve the max. And we get x is 2. We're interested in the x values, so read that part carefully. It says x values. 2 and 4, 3 and 5. Okay, so then they're the early marks, okay? And we've got to make sure we get them. You get about 5 early marks for this question, okay? Make sure we're getting those. Then we move into the part where it starts to get a bit more tricky. So if we look at my strategy here, early marks, do as it tells you, use your calculator unless stated otherwise. In both of those it says show that it's this, use an algebraic process, show that it's this. Okay, now we're on to developing the conjecture. All right, because if we look at the question, it says, make a conjecture about the x coordinates to this function. Based off the table, whenever you're filling in a table, make a conjecture. This is only worth 1 mark. Okay, so this isn't something to panic about or to get worried about. We can still earn marks later. This is just, if you can see it, brilliant. If you can't, move on. Okay, nonetheless, let's talk about how can we observe it. Here, we're changing this value here, this number. So I've got 1, and when I have the number 1, my 2 x coordinates are 0 and 2. When I have the number 2, my 2 x coordinates are 1 and 3. When I have 3, I have 2 and 4. So this one's not too bad. You can sort of see, well, this number just lies halfway between them, all right? 4 is halfway between 3 and 5. 3 is halfway between 2 and 4. Or maybe you can see, break it down. Think about one property at a time. Okay, this number here, if we just focus on the first stationary point, it's 1 smaller than this number. Okay, 2 is 1 smaller than 3. 3 is 1 smaller than 4, which means the first stationary point is going to be 1 number smaller than m. It's going to be m take away 1. Okay, the second number, focus on the second one, break it down. If I look at this number 2 to 3, oh, that's 1 larger. 3 to 4, 1 larger, m plus 1. And so the conjecture is x equals m take 1 or m plus 1. M plus or minus 1. All right, so what have I written up here? Use a table of values, use it, break it down into parts, and the last point is your conjecture must satisfy all values in the table. All right, so for instance, m take 1 as the first stationary point. All right, if m is 4, 4 take 1 is 3. 3 take 1 is 2. 2 take 1 is 1. So we know that satisfies all of the values. All right, if and then for the second one, all right, if m is 4, 4 plus 1, 5. 3 plus 1, 4. So you check it must satisfy all of them. If it doesn't, you got the wrong conjecture. Only 1 mark. Don't panic about that part. Okay, so here's where I really want to talk about the difficult marks, and I suppose this is the strategy that I'm leading up to. In the test, if you looked at the practice test, if you've looked at the conjecture booklet, there's only 2 types of conjecture problems. They're either about stationary points or they're about tangents. Tangents including tangents and normals. Okay? So there's only 2 types. And so I've written up here, that's the first thing you need to do. Is this question about tangents or stationary points? It's about stationary points. That's what we've been doing. We've been finding stationary points. Okay, so then we've got 2 things that we're going to do to get marks. For stationary points, we just find f dash of x of the general function. Don't do it for the first case, don't do it for the second case. There's a reason they gave us this general function. Find f dash of x, make it equal to 0, solve for x. Always the case for stationary points. Always. All right, you're always doing the same thing. Okay? Yeah, they're confusing functions, but it's like get as many marks as you can. We're going to differentiate at the moment. For a tangent, what's the strategy? Well, find the tangent to the general function. All right, so finding a tangent, what do we need? Point of contact, we need a slope. So you find those things, you plug it in, you try and find the equation of a tangent. So it's just normal maths, but with letters instead of numbers. Okay, so 2 strategies there, identify which one you've got and then just get as many marks as you can following this process. Now, okay, let's go through to prove this conjecture though. So we've got our conjecture that the stationary points are at m take 1 and m plus 1. And I do want to stress something here for this one in particular. So we said stationary points occur when the first derivative is 0. Okay, here's the function, plus 2x. This is g of x for the general function. All right, investigate the general case. All right, always do the calculus for the general case when you're proving your conjecture. So we want to find g dash of x and make it equal to 0. Doing stationary points, g dash of x is 0. Okay, so in order to differentiate it, first we must express it at the top of the fraction. Using the chain rule, we'll differentiate it in one step. That would be minus 2 times x take n to minus 2 plus 3. All right, so that's the first derivative. Now, all we have to do is find when does this equal 0. That's when the stationary points occur. All right, so let's try and write it a bit so that we can do it. I won't do that yet. We'll just have to take 2 equals 0. So we're trying to break this down. Now, there's a temptation here to expand it, all right? And my advice is don't expand things until you can't do anything else, all right? Leave things completely as they are until you can't do anything else. Because quite often you'll find there's a very nice way for us to solve a problem like this. Okay, yeah, we can make them have the same denominator and so forth. That's not even something we need to do either. So from here, I think maybe there's two strategies that are very direct, but there's quite a few strategies. This is a question from last year's exam, by the way, and students use all kinds of strategies, and this is even one where you can end up using quadratic formula if you adjust it accordingly. So maybe I'll show you how they develop a quadratic and then you can solve a quadratic, but then I'll show you a more succinct strategy as well. Okay, so if we make them have the same denominator, right? If I'm going to subtract that, oh sorry, it's a plus. That's a plus. If I'm going to add that, I need them to have the same denominator. So I'm going to multiply that term by x take m squared on top of x take m squared. Now they both have the same denominator, we can bring them together. So it's minus 2 plus 2 lots of x take m squared on x take m squared. And we're finding when does it equal 0. And because we're finding when does it equal 0, we're only interested in the numerator. All right? And that's the same as what we did in the first case. Remember, they're scaffolding that for you. We did this in the first case, except we had the number 1 here. We're doing the exact same maths, except we've got an n instead. So, if you want to solve from here, I think maybe from here, the two strategies are probably best exhibited. So from here, you could completely expand all of that, all right? And you would have a quadratic. You're going to have ax squared plus bx plus c, and then you have this number here. And so you have a, b, and c. You can use quadratic formula. It's not the most effective way. If I'm going to solve this, what I'm going to do is add 2 to both sides to get rid of that first. Divide both sides by 2. Square root both sides. And then move the m over. Alright, and that was our conjecture. That's a very beautiful, smooth way of doing it. Okay, it's the fastest way to do it. And notice I got there because I didn't expand it. Okay, so when you get to here, and I've got a number and a squared factor, I can perform that square root at both sides. Nonetheless, you can still arrive at the answer by expanding that and using the quadratic formula. So here, all right, it's not my expectation that everyone cracks the conjecture. They're hard, okay? There's like 4 marks that are challenging to get there, but you have to get the easy marks, okay? Start easy, and then when it gets to here, are we doing a stationary point? Yep, all right, that means here's my first derivative, make it equal to 0. Now I'm solving that, and then just do as much of that as you can, okay? If it's a tangent, find the tangent to the general function. Given the x value, find the point of contact, find the slope. Just get as many marks as you can. All right, so when in the test then, all right, you can start to think about, yeah, I'm pretty happy with these basic skills. I'm pretty happy with the early parts of the conjecture. I need to focus on, that's where I've got room for improvement. That's where I can start to develop marks. Because you notice the same thing happens with the optimization questions, doesn't it? That some of those are quite tricky to get, you know, show that the equation's this and so forth. But the calculus part, differentiating it and drawing a sign diagram and stating the optimal solution, we should be getting all of those marks. All right? So there's going to be easy marks, there's going to be hard marks. Make sure you get the easy marks, and the hard marks are just a sort of bonus. You know, you've got to try your hardest to get them. Okay, any questions about this this document here as such? Or I think it's a strategy I've just been trying to emphasise over and over. But get the early marks and then just get as many of the later marks as you can. And I'm confident a number of you guys will prove it. All right. Yeah, the one in the test isn't too hard, I don't reckon.